this GeoGebra investigation, we're going to look at the magnitudes of vector u and v, see if we can create a sum of those two magnitudes, and then we'll use that to actually calculate the real life distance. At the moment we have vector u and v. In here, I'm going to open up my calculator toolkit, and I'm going to define my length of two vectors u and v by giving it a variable. Equals, I go back here to 1, 2, 3, and select the magnitude. Now I can type inside this magnitude symbols, I can type in u plus the magnitude v. Press enter. I've now calculated the magnitude of u and v. If I wanted to do them separately, you could actually just type in magnitude u, and then I could type in magnitude v. So let's have a look here at the moment. The length of vector u is 2.53. The length of vector v, the magnitude, is 5.73. This lambda symbol is the magnitudes of them added together, the sum of the magnitudes. If you move point E around now, or any of the points, you'll see that these magnitudes on the left over here are changing. That's pretty helpful if you're modeling an assignment or you're trying to model something. So at the moment we have now a calculator that's adding up the magnitudes of u and v, which is multiple vectors. You can do more than just two if you have more vectors to find. Now to work out the scale, we could then add points in up here in my scale, which is E, F and G. Over here in measure, the length between F and G is 0.979. So scroll back down here to my calculator section, and I'm looking at lambda, which is 8.23. That's the length of C to D plus the length of D to E. That's adding it up on the spot for me. Now, if I want to actually work out the scale, I know that 200 meters on this map is represented by 0.979. So let's make another variable up. Let's call it beta. Equals my symbol up here, which is lambda, multiplied by 200, and I'm then going to divide by this 0.979. So divided by 0.979, if you're going to get technical, 0.33. It's now converted my calculations for the sum of the two magnitudes of the two vectors and converted it to a real life length, which is 1,681 meters. Again, if I move E around, look down here, it's calculating the real life distance on the spot. So if I was creating my vectors and moving them around, it's just going to continually recalculate.